to the lesson for Concept 13, skill number 5, problem solving. We're trying to find a pattern here. So this is just an example of something that you might end up seeing. So here we have a strip, and in this strip we have square units. And so for instance, this is one square unit, this is another square unit, and what they want us to do is they want us to find out how many 2 by 2 squares can be drawn in the strip. So let me give you an example of what a 2 by 2 square would be. This is one side of the 2 by 2 square, and here's another side right here, and so there is the 2 by 2 square. So we want to find out how many of these can we make up from a strip that has 100 squares going in one direction, but only 2 squares going up. And so let's go ahead and first of all we want to understand what that problem is. So take what the question is and try to pull out the important parts, and that's what they're asking us to do here. So they want us to read that problem and kind of pull out the important parts. And so what I've pulled out here is that the strip is 2 squares tall, and 100 squares long, and that's why I ended up sketching this little drawing here. And this break here is because I couldn't draw 100 squares going in one direction. So then I want to come up with a plan. How could I figure out how many there are? Well, here's one, and some people might think, well, here I could put another one right here. However, it doesn't say we can't overlap them. So let's find out how many squares we can do. So let's do the length of the strip. So for instance, when I draw one 2 by 2 square right here, this is one of them. This would be one 2 by 2 square, and how much did I use of the strip? Well, I only used 2 units of this strip. So there's 100 units going across, but I only used 2 units. Now if I make another one, rather than doing it right next to it, I'm going to do it right here. So I'm going to change the color here, and I'm going to go right in this region right here. So you see how it doesn't say I can't overlap these. How many of these 2 by 2 squares can I get in here? It's not like I'm cutting them out or anything like that. So there's another one. And so now I've only used 3 units of that strip. So for 2 squares, I have 3 units. Well, let's change it again. So let's try this time how many if I have 3 2 by 2 squares. Let's see where I'm at. Well, here's 1, here's 2. So I'll just again take this part right here and draw it out, 2 units, and there's another one. So I've used now 4 units of this strip. So 4 units right there. And I'll do one more here in one other color. And so I'll do it right at this stage right here. And go right in here and out. And then back up. And now I've made another 2 by 2 square. And so that is my 4th one I made. And I am only 5 units over. So looking at this, I can come up with a pattern. Well, if I continue it on, and continue this one on, so the number of squares after I've reached 100, well, notice that these lengths of strips are only 1 less than the number of 2 by 2 squares. So if I had 100 here, then the number I would have here would be 100 minus 1, which equals 99. And so what I'm saying is we can make 99 2 by 2 squares. And that would be our answer, because that's what they're asking. How many 2 by 2 squares can we make from a strip of 100 squares length? It's 100 squares long. So let's take a look at what we'll end up seeing next here. So our next problem has an angle here. And remember, angles go this way. So if I was to start at A is a point on this ray here. The ray goes P to A. And if I look at an angle, and I look at APB, I'm looking at this angle right in here. I always say this point here where the end point is, where the vertex is, I say that first. So they're asking how many angles have PA as a side. So PA is right here. But there is more than just this one angle of APB. So we have APB, angle APB, but I also have angle APC. And so I have this one right in here, and then I have another one. I have angle APD, and one other one here, angle APE. So that makes 4 angles, 4 altogether. And then it says, how many angles not already counted have PB? So this one right here. Well, I can't count APB because I've already used that one right here. So I need to try angle BPC, angle BPD, and angle BPE. And so that makes 3 angles altogether. And then again it asks how many angles not already counted can I have PC being one of the sides. So PC's right here, so I have just 2 of them. See, I have angle P, or actually CPD, and I have angle D, let's see, CPE. So again, that was CP to D and CP to E. And so that makes 2 angles altogether. And then they ask, how many angles not already counted have PD? Well, there was only one here, angle DPE. And that's it, just the one. So the total number of angles, well, we have the 4 and the 3. Those are already counted here. So I just need to add on the 2 and the 1. And when I add up all those numbers, well, it makes 7, 9, and 1 make 10 different angles I see there. So that's what you're looking at on that assignment on Concept 13 Skill 5, is looking for patterns. Good luck.